Here's the lesson today on segments, chords, and tangents. Really make sure you keep this straight from yesterday's lesson. Yesterday's lesson was about angles and arc measure. Today, we're talking about the segment length. What is true about the different segments in these circles? And our first theorem is chord-chord. If two chords intersect inside a circle, the product, multiplication, of the chord segments is equal. So you break each chord into its pieces, multiply the pieces together, and they're equal to each other. So PT times TR is going to be equal to TS times TQ. Secant segments theorem says if two secants intersect outside of a circle, the product of the secant, multiplication, lengths, and its exterior segment equals the product of the other secant length and its exterior segment. Whole lot of words. This is how you want to remember this. It's the whole times the outside part equals the whole times the outside part. So it's this whole length of this side times that piece, and it's this whole length of this side times this piece. Whole times the outside, whole times the outside when it comes to two secants. And so we can look at an example here. This is a two secant situation. Remember, if you're looking at the whole, you might need to add. So I have 29 times 9 is equal to the whole of this side is 10 plus x. Treat it like a whole number, put parentheses around it, times the outside part. If you forget those parentheses, you're going to have a problem with your distributive property. And so I have 261 is equal to 100 plus 10x. Subtract 100 from both sides. Divide by 10. And that's your answer. Now, tangent secants are very similar. I'm still going to have this whole times the outside part. If a tangent and a secant intersect outside a circle, the product of the secant length and its exterior segment is equal to the tangent length squared. So that's all you're going to change in this time is you're going to square it. So an easier way to think about this would be to say whole times outside part equals the tangent squared. So here we have a tangent secant. Remember to add. The whole is 12. So I have 12 times 3 is equal to the secant segment squared. So I have 36 is equal to x squared. Take the square root of both sides. And x is 6. I don't have to consider the negative value because it is a length. Here, again, I have a tangent secant option. The whole of the secant, 3x plus x. This whole length is 4x, so I have 4x times x is equal to tangent squared. 4x squared is equal to 100. X squared is equal to 25. Take the square root of both sides, and x is 5. Now we have to take a little side note. Way back in Math 1, you should have learned a formula called the quadratic formula. This was a formula that when we had an equation in this form, we could do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Check out the song videos and the additional resources if you want to hear the song for remembering this. This lets us find our values for x. So if I wanted to just quick look at an example to help refresh your brain, I could do something like 5x squared plus 10x plus 7 equals 0. This is my A, this is my B, this is my C. We leave the variables off, so I have the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. When you work that out, that gives you the answer for what x is when the y equals 0. So sometimes we are going to get problems that need that quadratic formula. So here, whole length here is 7. The whole length here is x minus 3 plus x plus 3, which is 2x. So I have 7 times 2 is equal to 2x parentheses times x minus 3. Distributive property over here. 14 is equal to 2x squared minus 6x. When I have an x squared and an x, the only way I know how to solve it is to subtract 14 from both sides and use the quadratic formula. Now remember, it's okay when you're starting to make yourself a little cheat list. A is 2, B is negative 6, and C is negative 14. Remember, my original quadratic formula has positives in between, so I might want to go ahead and change those to add the opposite so I can keep track. So now I'm going to use that quadratic formula, which is the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Now you need to work this out in pieces because this plus or minus right here is going to give me 2 potential answers. Now I'm only going to use maybe the positive one, but I do have 2 potential answers. So when I work this out, when I go to work this out, I'm going to work it out in pieces. So the opposite of 6 is 6. Opposite of negative 6 is 6, plus or minus the square root of 36 minus 4 times 2, if you want to change that to add a negative, times 14 is plus 36 plus 112 all over 4. So I have 6 plus or minus the square root of 148 all over 4. The square root of 148, 6 plus or minus, go ahead and use a decimal at this point, 12.2 over 4. Now this is 2 separate problems that I have to consider. I have to consider that 6 plus 12.2 over 4 is an answer, or 6 minus 12.2 over 4 is an answer. This ends up equaling 18.2 over 4, which equals 4.55, which works in my problem. Or this ends up being negative 6.2 over 4, which equals negative 1.55. When I go back and look at my problem, this value can't work because one of those was x minus 3, and that would make a negative number. This answer works, and so that is my value of x. It's a far more complicated problem than a lot of them, but the next 2 examples both use that quadratic formula. So, secant tangent. I'm sorry, 2 secants. It's a very little one, but 2 secants. So the whole, which is 2z plus 16, times the outside part, which is 15, is equal to the whole, which is z plus 9, times the outside part, which is z plus 3. This side over here is a distributive property, 30z plus 240. This side over here is a FOIL. First two terms, z squared plus outside terms, 3z plus inside terms plus last. Combine like terms on the right. Now I have 12z plus 27. I don't know how to solve things when I have a z and a z squared, so I'm going to subtract 30z from both sides. So I have 240 is equal to z squared minus 18z plus 27. And I'm going to subtract 240 from both sides. Get in my right row. And I'm going to have 0 is equal to z squared minus 18z minus 213. Now I'm going to apply my quadratic formula. So I'm going to go ahead and give myself a clean sheet to work this because I'm out of room. And so I have 0 is equal to z squared minus 18z minus 213. So A is 1, B is negative 18, and C is negative 213. If you think about adding the opposite, so I have the opposite of negative 18 plus or minus the square root of negative 18 squared minus 4 times A times C all over 2 times A. Now it's just a matter of cleaning things up. Always be careful with these negatives right here. This negative 4 and that negative are going to make a positive. So I have 18 plus or minus the square root of the square root of 1176 all over 2. 18 plus or minus the square root of that is 34.3 all over 2. Remember, this is two problems now that we have to think about. This is 18 plus 34.3 all divided by 2, or it's 18 minus 34.3 all over 2. This one I know is going to be negative because of the minus in the top. Don't have to consider it. This one works out to be 26.1.